All right, so next up is atomic mass. How much does an atom weigh? And so again, we can pull this information from the periodic table. If we look at nitrogen, you see the number below is 14.007. That means that a nitrogen atom weighs 14.007 AMU. Oxygen, 15.999. Fluorine, 18.998. But wait a second, this doesn't make a whole lot of sense if we think about it, because we just learned that there were different isotopes of elements. And so if you have a different number of neutrons, you're going to have a different mass. So what is this mass that we see on our periodic table? And all it is an average. It's a weighted average of all naturally occurring isotopes. So here's the example for neon. And we see this number, this is going to be our average mass or our atomic mass. However, what you need to realize is that it's a weighted average. It's a weighted average. So for example, if you had one person that weighed 200 pounds and 100 people that weighed 100 pounds, if you asked what the average weight was, it'd be much closer to 100 than 200, right? Because there's more of the people that weigh 100 pounds. And so let's take a look at that in case of neon. So the three main isotopes are neon 20, neon 21, and then neon 22. We can take a look at their masses. Remember, our protons and neutrons don't weigh exactly 1 AMU, so these numbers aren't nice and round. But neon 20 weighs 19.9924, neon 21, 20.9938, and then neon 22, 21.9914, right? So one thing we have to consider is the mass of each one. The next one we have to consider is the abundance. How abundant are these? How many of these are there? And so this comes in terms of the percent abundance. And you can look these numbers up as well. So most of the neon that exists on Earth naturally created is neon 20, and that's 90.48% of it. Neon 21, just a small fraction, 0.0 or 0.27%. And then neon 22, 9.25%. So how are we going to calculate the average mass? Well, the average mass is going to be the sum. That's what this symbol means. It means sum of. So we're going to sum a bunch of different things. And what we're going to sum is the mass of each isotope times its abundance as a decimal. Right? So we're going to take all of these components and then average them out to get an average mass. So first up, we have neon 20, which weighs this 19.9924. Right, and we can see its abundance is made out of this 90.48%. So we're just going to switch that over to decimal, so 0.9048. You want to be comfortable going from percents to decimals. You're just dividing the number by 100, so just divide by 100. And then this symbol tells us to take the sum of, so that's our first isotope. Next up, we'll sum the next isotope that weighs this 20.9938. And then we divide this 0.27 by 100. You'll get 0.0027. And then we just keep going for the last component. This one weighs 21.9914. So right, 21.9914. And then it makes up 9.25%. Divide that by 100 to get your decimal. you get 0.0925. Plug that all into a calculator, and you'll be left with an average mass of 20.180 atomic mass units, which, if we check on our periodic table, is exactly what our periodic table says. So the two numbers agree with one another. So be able to calculate atomic mass. Be careful, sometimes instead of being given all the parts and asked for the overall mass, sometimes you'll be given the overall mass and asked for one of the parts. So just check out your homework for that.